Next, we look into software health problem known as technical debt. So what is technical debt? First of all, it is a metaphor of looking at poor technical solutions in software as financial debt. And following this metaphor, we can think that, like financial debt, also technical debt has two problems. First, it must be repaid. And second, you must pay interest on the technical debt. And like financial debt, this repayment and interest, they increase future software development cost. If you do not repay your debt, you have to continuously pay interest in the debt. So if you have poor software maintainability, then adding any new feature is slower. So in this way, you pay interest when you develop software towards the technical debt. And in one report, Gartner estimated that the cost of technical debt is $500 billion US. And the technical debt is a long-withstanding problem, although it has had different names over the years. From Microsoft Secrets book from 1995 already, there was a ruled 20% tax for rewriting code, which meant that every development project in Microsoft set aside 20% of their development effort to reduce technical debt in the code, to rewrite the code, to improve the maintainability of the code. Then in year 2000, a book titled Refactoring, Improving the Design of Existing Code was published by Martin Fowler. And refactoring is basically a technique for source code level technical debt reduction. In 2018, MIT Press published a book by Adam Barr titled The Problem of Software: Why Smart Engineers Write Bad Code. And although all the examples here talk about code level problems, this concept has been extended way beyond code level problems. And this figure highlights the different debt types that have been identified in the research. So this comes from the article from Nicoli, a tertiary study on technical debt. And these are the debt types that are identified in the paper. So we can see that in the top right, we have this code debt, we have design debt, we have architectural debt, which is basically where most of the research activities has been involved. So code, design, architecture. But the concept has been extended to other areas like defect debt, test debt, build debt, people debt, process debt, versioning, requirements, documentation, usability. So it's like a general concept that can be basically extended to different types of problems in software engineering and in software companies in general. But from the scientific viewpoint, we don't know very much about these other debt types beyond architecture, design, code, and maybe test. Yet it's good to recognize these as well, and we will look into these different debt types next. So we have requirements debt, which is distance between the optimal requirements and the actual system implementation. So it means requirements that are only partially implemented, requirements that are implemented but they don't work for all cases, requirements that are implemented but in a way that doesn't fully satisfy all the non-functional requirements. For example, it could be that search feature exists, but it takes 15 seconds to get any search results. So it's from usability viewpoint, it's useless because the performance is not there. We can have people debt, so we might be hiring people in too late. And if they are hired too late, then the project is delayed because people are hired too late. We might have concentrated knowledge, so only few people, let's say only one people in a team knows how to do something. And if this person is in a vacation or or ends up in a hospital or something bad happens, then there will be problems. Also, any type of lack of skills in the team. So if you need like test automation skills and you don't have any test automation skills, then you have people debt. Continuing with the debt types, we can have defect debt, which means known defects that are in the defect database that have been reported and found. We also recognize that these defects should be fixed, but due to competing priorities, limited resources, they have to be deferred to a later time. So we have a defect backlog that is growing that we don't have time to fix, but although we know we should fix this. We can have depth in the software build process. We might have manual steps in the build process. We might have ill-defined dependencies, any types of thing that makes the build process more complicated or slower or manual than necessary. We can have automation test depth, so basically lack of or poor automated testing. And obviously, if you try, and every time you try to do a new release, and if you don't have enough automated tests, every time you have to pay interest on the missing test because you have to manually check them, or you have to take the risk and hope that they work and release it to the production and hope that nothing breaks down. So this automation test depth increases with the release cycle. If you go really fast release cycle, you have to pay continuing interest on your lack of test automation. We can have usability depth, inappropriate usability decisions that should be fixed. It's kind of like the requirements depth, but in a different sense. So problems in the software that affect the usability. We can have versioning depth. For example, we might have unnecessary code forks. If we have a common code base, but we have 50 different customers and we have a different fork for each customer where we do the fixes, then at some point this is no longer attainable. I mean, maybe it works with the 50, but what happens if you have 500 customers and you have each of them have their own development branch? Then you must have a very good process, or you must reduce the number of code forks or find other ways to do the configuration from the customer. So not doing it, for example, in the source code level, doing it maybe in a configuration file, and only the configuration file changes between the customer. So that might be a solution to the versioning depth. And we didn't go into very details into these different depth types. Next, we will look into anti-patterns, and we will look into the code smells that are really on the code level depth, and anti-patterns maybe introduce some other aspects of these. So we can consider the bad code smells and anti-patterns also under the technical depth, so as they are a part of a certain type of technical depth.